Everyone still thinks power in AI comes from buying more chips. That belief feels obvious, safe, almost unquestionable. But that belief is already failing, and the companies acting on it are about to find out the hard way. For years, the AI race followed a simple rule. If you wanted better systems, you scaled hardware. More chips meant more capability, more power, more advantage. That rule shaped everything: budgets, roadmaps, data centers, even national strategies. And for a while, it worked. But something quietly changed. Not because chips stopped improving, not because demand disappeared, but because more hardware no longer guarantees more usable power. The industry assumed intelligence scales cleanly with compute. Double the chips, double the results. That assumption only works under very specific conditions: cheap energy, unlimited infrastructure, predictable operating costs. Those conditions no longer exist. As models grew larger, the hidden costs started to dominate. Not just the price of the chips, but everything around them. Power delivery became harder. Cooling became a limiting factor. Inference costs exploded. Reliability became fragile. At small scale, these are background problems. At global scale, they become constraints. You can install more chips, but you cannot instantly expand a power grid. You cannot instantly solve heat density. You cannot instantly make inference cheap at scale. So something strange started happening. Companies kept buying hardware, but the returns started shrinking. More compute no longer translated cleanly into better outcomes. Training costs surged. Deployment slowed. Operating expenses ballooned. On paper, everything still looked fine. In reality, efficiency was collapsing. This is the moment when scale stops being an advantage and starts becoming friction. Because power is not just about how much hardware you own. It is about how effectively you can use it. Two systems with the same number of chips can produce very different results. One burns energy. The other extracts value. That difference matters more now than raw capacity. This is why efficiency is no longer a secondary concern. It is the new leverage point. If one company needs half the hardware to achieve the same output, they are not just saving money. They are avoiding the bottlenecks entirely. They avoid infrastructure expansion. They avoid grid negotiations. They avoid the compounding limits slowing everyone else down. Meanwhile, companies locked into brute force scaling face a problem. They cannot easily reverse course. They have already committed, already invested, already built systems that only work if scale keeps winning. That is why more chips no longer mean more power. Power now comes from managing constraints, from optimization, from doing more without demanding more from the system underneath. The AI race is no longer about who can accumulate the most hardware. It is about who can extract the most value from what they already have. Most people are still measuring power the old way, by counting chips, by tracking spending, by watching capacity announcements. But the real power has already moved. It moved to efficiency, to architectures that respect limits instead of fighting them, to systems designed for reality, not assumptions. Once you see that, the entire AI landscape looks different. And if you are still equating power with hardware, you are already behind.